Okay, this is part 2. We are looking at section 4.2, linear regression, least squares regression. And this point here, we're going to start out with interpreting the slope and the y-intercept of the least squares regression line is very, very key. There will be questions that will be asked on this. There's no question about that. So when we're interpreting a slope, okay, remember in algebra we learned the definition of a slope is rise over run, or the change in y over the change in x. So for example, if a line has a slope of 2/3, then if x increases by 3, again x is in your denominator, y will increase by 2. Or if you have a slope of -4, you can think of that as -4 over 1. So this tells us as x increases by 1, y will decrease by 4. So understanding that interpretation is extremely important of the slope. Okay, the y-intercept is a little bit more straightforward. The y-intercept of any line is the point where the graph intersects the vertical axis. It's found by when you let x equals 0 in an equation and then just solving for y. So in general, we can interpret a y-intercept as the value of the response variable when the value of the explanatory variable is 0. So to interpret the y-intercept, you have to ask yourself a couple questions. First, is 0 a reasonable value for the explanatory variable? Okay, if we're talking in like number of people attending a certain event, well, is 0 reasonable? Is it reasonable to have 0 people attend an event? In some cases, yes. Other cases, it probably makes no sense to calculate for 0 because it wouldn't be helpful. And then another thing is, do any observations near x equals 0 exist in your data set? If all of your data is x equals 100 and above, then x equals 0 may not be very helpful for you. So, and then one note on the right here I've got, so caution, be careful when using least square regressions line to make predictions for values of explanatory variable that are much larger or much smaller than those observed. Okay, so again, if your data values are between 100 and 200 and you want to make a prediction that is based off of an explanatory variable value of 500, that's well outside the scope. It's much larger. So you need to be very cautious. Try and stick close to the range of data that you have for your explanatory variable. Okay. All right, so let's take a look here. Income and education. So in a previous problem, there was a scatter diagram of correlation coefficient suggested there is linear relation between the percentage of individuals who have at least a bachelor's degree and the median income in those states. Okay, and then the least squares regression line for that was y hat is 703.5x plus 14,920, where y is the median income, x is the percentage of individuals 25 years and older with at least a bachelor's degree. So part A, we want to predict the median income of a state in which 25% of the adults 25 years and older have at least a bachelor's degree. Okay, so 25%. And says x is the percentage, so we are actually going to use 25 rather than 0.25 because x is the percentage. So to make this prediction, okay, y hat is going to be 703.5 times that percentage, 25, and then plus 14,920. Okay, when I multiply that together and then add 14,920, I get 32,507 and 50 cents. Okay, so that would be the predicted median income for a state in which at least 25% of adults 25 years and older have a bachelor's degree. Okay, in North Dakota, 27.1% of adults aged 25 years and older have at least a bachelor's degree. The median income is $37,100 193. Is this income higher than what you would expect? Okay, so in part B, what we're going to do is we're going to calculate our prediction based off of 27.1%, so 703.5 times 27.1 plus 14,920. Okay, and when I do this out, I get 33,984.85. And again, that is our predicted amount based off of the information that we were able to gather from the previous problem. Okay. So is this higher than we expect? In this case, the observed is greater than the predicted. So the value of 37,193 is quite a bit higher than we predicted. And one possible reason is that there have been a lot of jobs created over the last decade in North Dakota that are very very hands-on, intensive, and not all of them require a bachelor's degree, but they do require, a significant amount of skill. And so that could be one explanation as to why. I'm not an expert in North Dakota, but that's just my observation based off of a few things that I have heard about North Dakota. Okay, next we want to interpret the slope. Again, the slope is 703.5 over 1, technically. Okay, so remember that X is representing percentage of adults, Y is representing the median household. So what we would say is, I'm just going to shorthand this so it doesn't take up too much time, but if the percentage of population with at least a bachelor's, I'll just say that, increases by 1%, so that's the denominator. Okay, if that percentage increases by 1%, so I should say with bachelor's, just so we're clear here. So if it increases by 1%, then the median income increases by $703.50. And that's on average. It's not a guarantee, but that's just on average. Okay, so again, we look at the explanatory variable X, which is in percentage. So since we're 1%, so as X increases by 1, the Y value is going to increase by 703.5. So that's percentage of population with bachelor's increases by 1%. Then the median income, which is Y, would increase by 703 on average. Okay, and then part D, explain why it does not make sense to interpret the intercept. Okay, if we were to look back at the data, there were no observations close to 0%. And so it is outside the scope of the model is what we'll say. Okay. Most states will have I would say, estimate at least a double-digit percentage of people who have a bachelor's degree. So 0% as a Y-intercept just wouldn't make sense. It'd be way outside of the scope of the data that we have. So that would be how we would interpret it. Is kind of the technical term. It's just outside the scope of the model. Okay. So now we're going to look at height versus head circumference. Okay, and again, it references back to a question, but we have our data here, and we've got a pediatrician who wants to determine the relation that exists between a child's height, x, so again, x is the child's height, it's our explanatory variable, and the head circumference, which is a response variable. So she randomly selects 11 children from her practice, measures height, head circumference, and obtains the following data. So that's all of this data set right here. So this would be one individual, this would be a second, a third, and so on. And then she looked at 11. Okay, the first thing we want to do is we want to find the least squares regression line. And to find the least squares regression line, we're going to do this in StatCrunch. So I'm going to show you how to do this. So we've got all of our data right here. Okay, and when we got all of our data, we are going to go into Stat, Regression, and this is a simple linear regression. So x, we were told was the height, our explanatory variable is height. Y, which is our response variable, we were told was head circumference. And let's see here. We're going to compute, and you can see right here, here's our slope, here's our y-intercept. And you can see right here we have the head circumference, which was y, equals the y-intercept plus the slope times the height. So this will be part A. Whoops, don't need the highlighter. It's part A. Y hat equals that slope, which was 0.1827, I'll round it there, x, plus 12.4932. Okay, and that's the least squares regression line. Now we want to interpret the slope and the y-intercept. Okay, so for our slope, think of it as 0.1827 over 1. So we would say an increase of, again, the denominator is x or height, an increase of 1 inch in height results in an increase of 0.1827 inches in head circumference. And we'll say on average. Again, it's not a guarantee, but that's on average. So that would be our slope. Okay, the y-intercept would not be appropriate. So we'd say the y-intercept is not appropriate. First, that would tell us that we have a height of 0, so we don't have anything. No baby exists. And it's also, so we'd say 0 for a height is outside of the scope of the model. Okay, so that would be how we would look at and interpret the y-intercept and the slope. So I'm up against the clock. We'll finish off the rest of this question. I believe this is our last question that we have, and we'll finish it off in our last part 3 for this lesson.